Hello. In this video, we're going to do a quick showing of how we can use the rational root theorem to determine a list of possible rational roots for a polynomial. All right, and if none of those possible rational roots lead to the function being zero, then none of the roots of the polynomial are rational. And either the roots of the polynomial are complex or they are irrational. So let's say that we have a polynomial given by the following, that we have f of x is a to the n, or a sub n x to the nth power, plus a sub n minus 1 x to the n minus 1 power, all the way down to a sub 1 times x plus the constant a sub 0. The possible rational roots are given by the factors of the constant divided by the factors of the leading coefficient. The reason for this is the following. Let's say that you had y was equal to some polynomial that was written in a factored form, and one of the factors was bx plus c. Well, if that polynomial is going to be equal to 0, then one of the factors must be equal to 0, and if we solved, we'd see that we would have, right, opposite c over b. Well, what does that tell us? That tells us that all of the roots that come from factors that might be written as linear factors are going to depend on something related to the constant divided by something related to the leading coefficient. So in this situation, right, we're going to be looking at the factors of the constant divided by the factors of that leading coefficient. So here for this cubic function, 2x cubed minus 5x plus 3, we'd have possible rational zeros of plus or minus 1 half, plus or minus 3, plus or minus 1 half, plus or minus 3 halves. And this should not both be plus or minus 1 half. This should be a 1. Right? And the reason for it is that the factors of 3 are plus or minus 1, plus or minus 3. So I'm going to have plus or minus 1 all over plus or minus 1, plus or minus 3 over plus or minus 1. Then I'm going to have plus or minus 1 all over plus or minus 2, and plus or minus 3 all over plus or minus 2. So my possibilities, once again, are I could have plus or minus 1, plus or minus 3, plus or minus 1 half, plus or minus 3 halves. Those are my only possible rational roots. So let's look at it in practice. So the possible rational roots for this function, right? So my possible rational roots, right, are going to be plus or minus the factors of 6, right? The factors of 6 are 1, 2, 3, and 6, divided by the factors of this implied 1, and that is just 1. So my possible rational roots are 1, 2, 3, or 6. Those are the only possible rational roots. So if I want to find the linear factorization, right, I can't quite factor this by grouping, but it is a cubic polynomial. I could come in and say, hey, well, what if x was equal to 1? Well, if x was equal to 1, I'd have 1 plus 2 minus 5 minus 6, and that's not 0. So we know that x plus or x minus 1, we know that x minus 1 is not a factor. And if we consider f of negative 1, well, that's going to be negative 1 plus 2 plus 5 minus 6, and that does equal 0. So therefore, x plus 1 is a factor. And we can get to our linear factorization by doing Ruffini's rule, synthetic division, or by doing long division. Since x plus 1 is a factor, I'll go ahead and do this approach doing Ruffini's rule, doing synthetic division. I'll say, hey, I've got a negative 1. Coefficients of my polynomial are 1, 2, negative 5, and negative 6. Bring down the 1, multiply, add, multiply, add, multiply, and then that's 0. So that tells us that f of x can be written as x plus 1 times x squared plus x minus 6. But we want the linear factorization, which means we need linear terms, And so that means that we're going to factor this x squared plus x minus 6 if possible. So we have x plus 1 times x, let's see here, we'd have plus 3 times x minus 2. And so I've got the linear factorization for my polynomial. And I did it using the rational root theorem to just get me started. The rational root theorem historically was useful when you did not have calculators and other high computation ability technology, but nowadays it is useful for seeing how adept a student is at understanding the algebra approaches for solving polynomials historically. Thank you for your time.